Hi guys, welcome to my channel. So in the previous video, I have discussed about recursion and recurrence relation, and we have also taken an example of the factorial program. So in this video, I'll be taking some more examples of recursion to understand it better. So our first example will be multiply m and n using recursion where m and n is greater than 1. So what we want to do is, like, if you are given m is equals to 3, n is equals to 2, our output will be 6. So what will be the intuition for doing this program using recursion is, like, 3 into 2 is nothing but adding 3 two times, is 3 plus 3, 6. I will take another example, 4 into 3. So what 4 into 3 means? Adding 4 three times, like 4 plus 4 plus 4 is equals to 12. So using this intuition, using this two intuition, using these two intuitions, we will try to write a recursive program. So let's say you have a function multiply which takes in two inputs m and n. For this example, I will take m is equals to 4, n is equals to 3. So you can write it like m into n plus multiply of m comma n minus 1. So what does this mean? Let's understand this by taking this example. You have multiply 4 comma 3. So this will come, and you can see this is m, and this is, we are again calling multiply. So m is 4 in plus multiply of 4 comma 2. Again this will be called, this will be 4 plus multiply of 4 comma 1. And as we have discussed in recursion, you should at least know the output of the base case. So here we can take this as the base case, because 4 into 1, we know it's 4. So this will return 4. So 4 plus 4 is 8. So we will return 8 here. 8 plus 4 is equals to 12. So we have got our answer. So let's try to implement our base case here. So base case is 1, n is equals to 1. So if n is equals to 1, we will return m. So this basically becomes your program for finding the multiplication of two numbers using recursion. So let's see what will be the recurrence relation for this. As we know, recurrence relation is nothing but writing a function in terms of its smaller version. So the recurrence relation will be multiply m comma n will be equals to m if n is equals to 1. This one. When n is equals to 1, we are returning 4. So m, and or else it will be m into multiply of m comma n minus 1. So we will not take this into account because this is a non-recursive term. So we will take only this one, multiply of m n minus 1, and if n is greater than 1. So this one is this one, and this one is this one. So if n is equals to 1, we are returning m, right? If n is equals to 1, we are returning m. So for the value of n, we are returning the value of m. Otherwise, it is like multiplication of m n minus 1. So this is the recurrence relation of this. So what will be the time complexity of this? The time complexity of this will be O of n, because you can see we are multiplying it 3 times. So this is 1, 2 and 3. This you can think of this as a loop also, because you can see the value of n determines how many times these statements will run. So if n is equals to 3, it will run 3 times. If n is equals to 2, it will run 2 times. So the time complexity will be big O of n.